Hey guys, and welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about callback functions. So first of all, we're going to talk about like what is a callback function and how can we use a callback function in Keras and TensorFlow, and then we're going to look at some of the different kind of callback functions that is already built into TensorFlow and Keras. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come chat with us and talk about like neural networks, deep learning, artificial intelligence, computer vision, and also if you have a project where you have some problems, you can ask the questions in there or just get some inspiration for your own projects. You can also be a member of the channel here if you hit the blue button under the video here, and you can then support the channel with a small monthly fee, and everything will go to like creating better content and better quality gear for better videos for you guys. So jump into the first slide here where we're going to talk about like what callback functions actually are and how we can use them. So a callback function is a function which is accessible by another function. So when we actually like have callback functions, they get called by other functions. So a callback function is actually like invoked after the first function if that first function completes. So let's say we have one function that is running, like for example, when we're training on neural networks, then one function is running, and when that function it completes, then it will actually like invoke the callback function, and we can do some different kind of stuff within like our callback function, like for example log some of the data when we're training on neural networks, or change some of the parameters when we're actually like calling these callback functions when we're training our neural networks. So it's useful for like asynchronous behavior where we want an activity to take place whenever a previous event completes. So that could, for example, be after each epoch, or like for example after each batch, like we have passed a whole batch through our neural network. Then it can be useful to actually like have these callback functions to change some of the parameters, or just log some of the data, or store some of the parameters and the weights when we're actually like doing training of our neural network, which is really useful when we're training like really large neural networks and it takes like hours and days to actually like complete the training process of that neural network. Then it's really useful to use these callback functions here to, for example, reduce the learning rate, log some of the data, store some of the weights if the loss doesn't decrease or like the accuracy doesn't increase. So it can be used to change the values, parameters during function calls, which could be like when we're training on neural network, and it can be used for logging and storing relevant information on the way and during the training process, as I've already mentioned. So let's now talk about some of the callback functions that we have here available in Keras. So I'm going to specifically go into details with some of these different kind of callback functions here, and we're going to look at the API documentation for what these callback function here does. And then later on, I'm going to create another video where I'm going to show you how we can actually like create our own callback functions, which is really useful if we want to do some things like within epochs in our training process, or if you want to like specify some parameters or log some data like in the start of the training process or at the end of the training process. So that's really useful when we're training large neural networks and stuff like that. So I'm going to create another video where I'm going to show you how we can actually like create our own callback functions. But in this video here, we're going to focus on these callback functions that we have available from Keras and TensorFlow. So we have some different kind of available callbacks here, where for example have like a model checkpoint, so we can actually like have a checkpoint, so we can store our neural network architecture and the weight of our neural network when we're training. So if we, for example, hit a global minimum in the loss function and stuff like that, then we can actually like store that model before it begins to overfit and stuff like that. And we can also have some early stopping here, like if we're, for example, training for 100 epochs and our model doesn't increase more after, like, for example, 30 epochs, then we can have our neural network stop if it hasn't like increased or decreased in the metrics that we're looking at for some certain like time or like a number of epochs. We can also have a learning rate scheduler, so we can specify if we want to decrease or increase the learning rate while we actually like training the neural network and when we want to do that. And we can also have like reduced learning rate on plateau. So if our neural network isn't like improving over the number of epochs, then we can actually like reduce the learning rate by some factor, which we're going to see in code later in this video. We can also have some different kind of logging information or logging callback functions, where we can, like for example, like we can terminate on not a number things. We can have a CSV logger, so we can actually like log the data while we're training the neural network to a CSV file and stuff like that. So it's really useful for storing information and changing some of the parameters while we're training really large neural networks when we're using these callback functions here. So they're really important to know about. So one example here of the callback functions in Keras here that we're going to see in code as well is this model checkpoint here. So this model checkpoint here, it actually like just stores the best model when we're training our neural network. And then if a new epoch, if in a new epoch we get a model that is better, then it will just override that previous neural network, and then we keep storing the best neural network in our training process in the neural network. So for example, let's say we're training our epoch for like our neural network for 100 epochs, then maybe after 30 epochs we hit the best model, or like the local or like the global minimum of our loss function. Then we can actually like store that model. Instead, our neural network gets destroyed after 100 epochs because we start to overfit in our neural network. So we have some different kind of parameters here that we can specify, and these are like default parameters for all of the callback functions that we have in Keras. So often first of all here we have this file path here that we need to specify. So the file path where we want to store that model during training of our neural network. Then we need to monitor here a metric that when we're training the neural network, and often we want to look at the validation loss. We could also look at the accuracy, but often the default parameter here is the validation loss. So if the validation loss decreases even more, then we actually like have a better model, and we will store that instead. We can also have this verbose here, so we can see like the different kind of metrics while we're training and using these callback functions here in Keras. We can specify if we want to save only the best model here, and only if we only want to save the weight here when we're calling this model checkpoint function here after each epoch in our neural network training. We can also set the auto mode here if we're looking at if the value, or like the value or the metric here that we're monitoring, if that value is either like increasing or decreasing. We can specify here in this mode, but often we'll just set it to auto, and it'll find out that if we're looking at the validation loss, then it's better if the validation loss is decreasing, and it should look at like the lowest validation loss and then store that model. And we also have some like save frequent here where we can specify when we want to save that actual model, and often we will just save the best model after each epoch. So if our neural network is actually like increasing and it gets more accurate, then we will save that model after each epoch. So next callback function here we're going to look at is reduce learning rate on plateau. So we have some different kind of parameters here that we can specify with, for example, the monitor here. So what metric are we looking at? A factor here, like the factor that we want to like scale our learning rate on, like when our neural network isn't improving. We can also specify the patient here, which is set equal to 10 as default. So if our neural network isn't increasing in performance or in accuracy for 10 epochs, then we run out of patient, and we will then reduce our learning rate with a factor of 0.1 in this example here, when we have specified these default parameters here. And then the rest here is just like the minimum delta value we can have, and also we can specify the minimum learning rate. So if we don't want to go lower than some minimum learning rate, we can also specify that here. Or else we have this auto mode here when we're looking at the metric that we are monitoring when we're calling this reduce learning rate on plateau callback function. So this is just to give you a short introduction to the next video I'm going to do, where we're actually like going to create our own callback functions. So we can actually like create our own functions where we can specify some of the different kind of parameters, and we can look at the different kind of metrics of the training of the neural network. And then we can specify the functions here, like for example, if we want to specify something when we begin the training of a neural network, or when we end the training of the neural network, then we can do some logging and stuff like that. And also on the end of an epoch, or like in the beginning of an epoch, we want to do something, print something out, change some of the values, and we can do this for all of the different kind of things. We can do it after each epoch, after each batch that is passed through the neural network, and stuff like that. So that's also really cool. And remember to subscribe to the channel here, and also hit the bell notification so you get a notification when I upload the next video here about callback functions, when we're going to create our own callback functions later on. So we're not just Google Colab here, and I'm going to show you how we can actually like use these callback functions here that we just talked about in actual code. So first of all here, we're going to use an example with the MNIST dataset that we're going to create a neural network on, and then while we're training that neural network, then we're actually like going to call these different kind of callback functions. So the first couple of blocks of code here, I'm just going to go over them. We have already been over the blocks of code here in the previous videos. So if you haven't seen that, like how we can create a neural network from scratch here with Keras, and then use a dataset, the MNIST dataset with handwritten digits, and then we're going to create the neural network, train on it, and actually like do predictions. Make sure to check that video out before you're going to this one here, because we're going to create that neural network exactly from that video, and then we're going to use that. And then when we're going to train it, we're going to use the callback functions that were mentioned in the slides in this video. So first of all here, I'm just going to import the different kind of modules that we need. So we need NumPy, TensorFlow, and then Keras here, and the different kind of layers and models from TensorFlow. And then we're going to import the MNIST dataset here, which is just a handwritten digit dataset that we're going to use. And then we're going to use a matplotlib here to actually like show the images that we have in our dataset. We're going to run the blob of code here so we can use the GPU to actually like train our neural networks and do predictions on the GPU here in Google Colab. And then we're just going to import the MNIST dataset here. So we're going to split it into two datasets. So we have our training dataset and we have our test dataset, and we have both the images and also the labels for our datasets. Then we're going to do some reshaping here, so we actually like have the right shape to pass through our neural network. So we have to specify the dimensions of our images here, and then we need to specify the batch size and also the number of channels that we have in our image. So I'll just going to run this block code here. We will download the data set here from TensorFlow from the TensorFlow website here, and then we actually like have the first batch here of our handwritten digits, which is 50419. And then I'm going to create a function here just so we can plot the images that we actually like have in our data set. And then later on when we're going to make predictions, so we can actually like show the images and see if our predictions are correct with a neural network. So we're going to run this function here, and then we're going to plot the first 10 samples of our training set. So we can see here that we get the first 10 images here of our training set, and we can see up here that the first 5 samples is 50419, and these are also the images down here. So we have 50419, and then the last 5 samples here of the first 10 samples is 921314 in this example here. So these are the images here that we have in our data set, and then we're going to train our neural network on this data set here, and then later on we're going to do predictions. So now we're just going to create this convolutional neural network here where we have some convolutional layers and max pooling layers. And if you don't know like what is going on in this sequential model here, make sure to check that video out that I just mentioned, so you know like each step here, what is going on, what does the convolutional layer do, and what does max pooling do when we apply that between our convolutional layers and stuff like that. So I'm just going to run this model here so we actually like create our sequential model here or our neural network here in Keras. And then when we have done that, we can do a summary of the model here, so we can see that we actually have created this neural network here with a number of parameters. We first have our feature extracting block here, neural network, and then we have our dense or fully connected layers here at the end, so we can actually like do classification of the MNIST dataset. In the last layer here, we actually like have 10 output neurons because we're going to do predictions on images. So we're going to predict from numbers to 0 to 9, which is 10 different classes that we can predict on. So that's why we have 10 here in the output, 10 neurons here in the output layer. We have 1.6 million parameters that we're going to train on when we're going to train our neural network here and use the callback functions within that training process. So if we go down here, first of all, we need to compile a neural network with an optimizer. We need to specify the learning rate that we want to use for that optimizer. We're going to use a sparse categorical cross entropy, and the metric that we're going to use is the sparse categorical accuracy. So we're going to look at the accuracy of the neural network while we're training as well. So I'm just going to compile the model here again, so we can actually like start training the neural network with our callback functions. So before we're going to train our neural network, we need to specify the callback functions that are mentioned in the slides as well. So first of all, here we need to import these different kind of callback functions that we're going to use. So we're going to from TensorFlow.keras.callbacks here, we're going to import model checkpoint, early stopping, and reduce learning rate on plateau. So we're going to have model checkpoint here so we can store the best model while we're training for each epoch. And then we're also going to use early stopping. So if a model doesn't increase anymore, then we're going to stop the model or like stop the training process because our model is not increasing anymore. So it doesn't really make sense to train it for more epochs. And then we're going to reduce our learning rate. If our model doesn't get better for some epochs, then we're going to reduce the learning rate and see if we can improve the neural network even more. So first one here is that we're just going to have this variable where we're going to store this callback function. And then first of all, we need to specify the path where we're going to store the best model while we're training on neural network. We're going to look at the validation loss of our neural network. So this is the variable or like the metric that we're going to monitor. We're going to save the best model only, so we set that equal to true, and the mode here is just default to auto here as well. So now we're going to create this callback function here with the model checkpoint, so we can actually like store the best model while we're training on neural network. The second callback function here that we're going to use is the early stopping. So again, we're just going to monitor the validation loss. So if the validation loss doesn't decrease for 5 epochs, because we're specifying the patient here to be equal to 5. So If our validation loss is not decreasing for 5 epochs, then we will just stop the whole training process of the neural network, and then we will restore the best weights here because we set that equal to true, and then we can then actually like use that model as the best model, and we can store that here in the best model .h5 here. So we both have the best model that is stored while we're training, and if our neural network is not increasing anymore, then we will stop the training of the neural network here as well, and we will restore the best weights in the training process. We're also going to specify this reduced learning rate here, and we're going to have this reduced learning rate on plateau. Again, we're going to specify like monitor the validation loss. We're going to have this factor of 0.2. So when our learning rate, if we need to reduce our learning rate, then we will reduce it with a factor of 0.2. We have a patient here of 3, so if our validation loss is not decreasing for more than 3 epochs, then we will reduce the learning rate here by a factor of 0.2, and we also specify the minimum learning rate here to 0.00001. So this is the minimum learning rate that we can actually have when we're training on neural network. And the reason why we have a patient here of 3 is because if we, for example, had like a 5 or 6 or above that, then we will actually like not reduce the learning rate, because if our validation loss hasn't decreased for more than 5 epochs, then we will stop the whole training process with this early stopping callback function up here. So we need this patient number here to be less than the patient number that we have up here in the early stopping, because if our validation loss isn't decreasing for more than 3 epochs, then we will just reduce the learning rate here, and then our model can actually like learn more, and the validation loss, we have the possibility that our validation loss actually like decreases even more before we're calling this early stopping callback function here, because it will be called when our validation loss has decreased for 5 epochs. So these are the 3 different kind of callback functions that we're going to use while we're training this neural network. And then we have these blocks of code here where we're going to kind of like create our own callback functions, which we're going to see in the next video. So if we just skip down here to training the neural network with these callback functions here, then we're just going to specify the different kind of parameters, as we already did in all the other videos where we created neural networks and trained them on data sets. So we have the batch size, we have the number of epochs that we're going to train it on. We can actually like train it for more epochs. We have these steps per epoch here, validation steps. But when we're going to specify the callback functions we're going to use, we have to specify at the end here callbacks, and we set that equal to this list here, where we actually like have these callback functions here that we specified up here. So we just have a list of our callback functions that we want to use when we're training our neural network. So if we run this block code here, we will actually like call this fit function here and actually like train the neural network. So now our neural network training process has started here, and we can see that we're at the first epoch out of 30 epochs. So our neural network is now done training here, and I've just zoomed out a bit here so we can actually like see what is going on. So first of all, here we can see that we have a really high loss here for our training data for the first epoch that we're training our neural network on. And then we can see the validation loss here is actually like really low, so we have 0.07 here. So because we have the lowest, because we start with an infinity loss here, we're going to save the model here after first epoch, because then the validation loss is actually like the best validation loss that we have seen so far. So it just says here, this callback function, the validation loss improved from infinity to 0.07, and the model is saved to this file path here that we specified, and we have now saved the best model here in this best model file here, .h5. Then we're going to train the neural network again for the next epoch, and we can see that our training loss here is actually like decreasing a lot, and we can also see that our training accuracy here is also increasing. If we look at the validation loss, which is the metric that we're monitoring while we're training the neural network here, we can actually like see it actually like decreases from this epoch to this epoch by a factor of 0.02. So our model has actually like improved in validation loss. So we're now saving the new best model to this file path here that we specified, and we're then overriding the previous model here that we stored up here after the first epoch. Then we're just going to do the same thing for the next epoch, and we can see that our validation loss is again increasing. So we're overriding the best model again, because our neural network has actually like improved for the next epoch that it has trained on. But we can see for the next epoch here, or the fourth epoch here that we're training our neural network on, we can see that our validation loss here is not actually like decreasing anymore. It actually like increases. It was actually like increasing from the last epoch here. So we can see that we're not saving now we're not saving the model anymore. We go to the next epoch, our loss, validation loss here, it decreases. We're saving the next best model. Then we go to the next epoch. It is actually like increasing. This example here, it is still increasing. It is still increasing. So now it has increased 3 times. So we're actually like going to lower the learning rate because we specified the patient to be equal to 3 up in our callback function, where we're going to reduce our learning rate while training. So then we're actually like going to reduce the learning rate here by a factor of 0.2. So now we have reduced our learning rate, and we want to see if we can actually like improve our neural network even more. So we can then see after the next epoch here, we actually like decrease our validation loss here. So we actually like get a better model when we have decreased our learning rate here, or at least reduced our learning rate. So now we have a validation loss of 0.039 here, and this is now the new best model. And by using the callback functions, we're now saving that model and overriding the previous best model. So now we have the best model stored in this file path here that we have specified. Then we go to the next epoch, do the same thing. Next epoch, do the same thing. We can see again, we go to the next epoch after two times here, or 2 epochs that our validation loss hasn't increased on. So we're again reducing the learning rate. We do the same thing here again, but now we can see that our validation loss hasn't increased for 5 epochs. And because we specified the early stopping at 5 epochs with the patient, then after our neural network hasn't increased or like hasn't improved for 5 epochs, then we're actually like just going to stop our neural network, or like stop the whole training process. And we can see that we only trained our neural network for 17 epochs out of 30. So we actually like want to train our neural network on 30 epochs, but because we have this patient of 5, then when our neural network hasn't increased or like decreased in the validation loss for 5 epochs, then we're just going to terminate the process, and we're not going to train our neural network anymore, because we think that we have found the global minimum here with our loss function. So this is how we can use callback functions when we're actually like training on neural network. And in this example here, we both like reduce the learning rate, we're saving the best model, and we're actually like also doing early stopping if our neural network isn't increasing anymore. And you can actually like just specify as many callback functions as you want. It will probably just get a bit more complicated, but in theory, you can actually like just specify all the callback functions you want, and you can even like combine these with your own callback functions that you're going to write if you want to like store some of the data, store some of the weights, or like at least store some of the weights for some of the layers. Or you want to specify some metrics, you're going to like store like more metrics while training your neural network here. You want to like store all the different kind of metrics here and output that to a CSV file. You can actually like do that after every epoch, or like in the start of the training process, or at the end of the training process. So there's a lot of different kind of possibilities and variabilities when you're actually like working with callback functions in the training process of a neural network. And just to end this video out here, we're just going to plot the results here from the training process, and also the training loss here and the training accuracy. So we can see here that our validation accuracy here is actually like increasing over the epochs, and our training accuracy here is also increasing over the epochs here. So we can see that our neural network is actually like learning from epoch to epoch, but we can see that it converges towards a global minimum here for our like a global maximum for our validation and training accuracy. And down here with the loss, it is the same, where we keep increasing until it doesn't increase for more than 5 epochs, and then we have and then we think that we have hit a global minimum for our loss function, and we just terminate the training process, because we think that we have found the best model, or like the best weights for our neural network on that training set that we're training our neural network on. And at the end here, we can actually like do predictions with our neural network. So we're just going to evaluate our neural network on the whole test set here that we're going to run. So we can see that we get a loss on the whole test set here of 0.04, and we get an accuracy of 99%. So we're actually like in 99 out of 100 examples, we're actually like predicting the correct result. And if we're just going to plot the images here and see the first 10 samples of our test set here, and see if we actually like predicts the correct the handwritten digit here, then we're just going to plot the images first here, and we're going to create predictions here, use the argmath functions as in all the other previous videos. And we can actually see here that we're predicting that the first image here is a 7, the second image is a 2, the third image is a 1, 0, 4, 1, 4, 9, 5, 9. So we can actually like see that we're predicting all of these handwritten digits here correctly, and our model has a really high accuracy with a really low loss, and we actually like improved both the loss and also the accuracy by using these different kind of callback functions. and we can actually like go back and take the best model during our training process by just loading in the model that we actually like stored to the file path that we specified. So that's pretty much it for this video here, guys. We've been over the different kind of callback functions that is already built into Keras, and also why we should use callback functions and how we can use callback functions. So these are really important when we're training large neural network for like several hours or like even like several days when we can't be at a computer all the time. Then we can actually like create callback functions to tune some of the parameters or lock some of the data that we can actually like use after that to do some post-processing of our neural network data. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in the future. It really helps me and the YouTube channel out in a massive way, and I just really appreciate the support. I'm calling us doing a computer vision tutorial where we're doing some image processing. We're doing camera calibration, stereo vision, where we're estimating like depth to different kind of objects. We're doing object detection and a lot of different kind of cool stuff. And we're actually like going to combine computer vision with deep learning and stuff like that. So if you're interested in the computer vision tutorial, I'll link to it up here. Or else I'll just see you in the next video, guys. Bye for now.